Well, yeah, to work out this particular question, where we've got the probability of it being fine is equal to 0.6, and the probability of it being windy is equal to 0.3, and the probability of it being, where is it, windy and not fine, so not fine, that's the with the complementary, is equal to 0.2. So what I'm going to do is I'm actually going to draw a Venn diagram because I think it's actually a really good way of showing it. Some people could draw a table if you wanted to, but that's fine. I'm just going to do a Venn diagram. So the blue circle is where it's fine, so that's 0.6. And I'll do the red circle is where it's windy, which is 0.3. Okay, now what you've got to think of here is where is it not fine, but it's also windy. So where it's not fine, and I'm going to shade this in and then I'm going to take it all away, where it's not fine is all of this, isn't it? This is not fine, including this part of the windy, that's not fine. Okay, and we're told that where it's the windy part of where it's not fine, the windy part of where it's not fine is this bit here. And we're told that that is 0.2. So I'm just going to take that away because we're told that this area of yellow here is 0.2, which means this middle bit here has to be 0.1. So I'm just going to take away some of all of that, just so we can get it all back. So we're told that this part in here, when you saw when I shaded it in before, that is where it is windy but not fine, is in this area here. So that's 0.2, which means that this little bit in here is 0.1. Now, if that's 0.1 where the intersection is, therefore the probability of where it's fine and just fine and not windy, therefore it must be 0.5. Okay, so basically the probability that the weather is fine and not windy therefore equals 0.5. And that's how you work it out.